Hi, and welcome to this introductory class on FPGA-augmented cloud infrastructures. The objective of this class is to be a sort of bridge to connect Xilinx XDXL and all the topics covered so far in this course to the developing FPGA-accelerated cloud application with XDXL course. Let us start with a simple consideration. The more general purpose you are, the more flexible you are, the more kinds of programs and algorithms you are requested to execute on your underlying computing infrastructure, and all of this is happening, quite often, by losing in efficiency. Companies like, named in alphabetical order, Alibaba, Amazon, Baidu, Facebook, Google, Microsoft, and Tencent, are experiencing a significant growth in key workloads, and they are definitely not okay with the idea of losing in efficiency since they are making business out of it. Not only, these workloads require more performance than can be obtained even by using the fastest CPUs. Therefore, this scenario is turning cloud and data center architectures toward accelerated computing. And this is done because accelerators complement CPU-based architectures and deliver both performance and power efficiency. Now, as far as it seems, within this context, the problem is being able to choose the right accelerator. And this is true because there are several accelerators that can be used. On one hand, GPUs offer better parallel performance, more efficient computing, and easy-to-use programming model. On the other hand, FPGAs bring higher performance per watt, improved hardware acceleration performance, and lower inter-device latency. Moreover, when used in cloud infrastructures, the advantages introduced by extending these infrastructures with FPGA technologies are even more clear. In the context of a cloud infrastructure, FPGAs are essentially a system-on-chip coupled with one or more host CPUs via PCI Express connection. This scenario is basically turning FPGA into a custom accelerator for the code running on the CPU. Now, this is extremely interesting and convenient because FPGA resources are ready to be used upon purchase and can be elastically scaled. The ultra-large-scale resources pool can meet the need for greater numbers of FPGA resources during business peaks. FPGAs are reconfigurable devices. Therefore, they can provide an ideal fit for the changing workloads of the modern data center. Now, considering all these advantages, why FPGAs have been only recently used in cloud infrastructures? It is because of the cost of doing FPGA engineering. As this course was all about, programming an FPGA was definitely not an easy task. Therefore, if you can only hire a few experienced engineers, there is only so much you can do. You end up quite soon in a scenario where you cannot go to the market with the velocity you were looking for, and this is exactly the reason why cloud providers are investing so much in FPGA extended solutions. FPGAs have been proven to be really effective. What was missing was a surrounding developing ecosystem, which is exactly where a significant portion of research is going right now. And this is exactly the rationale behind the work done by Xilinx with the XDXL design framework and Amazon with the F1 instances. In the following, we will see how to use Amazon F1 instances and how to program them because of the Xilinx XDXL framework to design and create your solutions.